Jacob Andreas is an associate professor of electrical engineering and computer science. He's a principal investigator at CSAIL. Thanks so much for being here.
Thanks for having me.
So I'm going to start with a question that sort of touches on what we were talking about before the camera started rolling here and the audio started rolling. If you think back to when you were in college, to when you were in grad school, could you have ever imagined the kind of excitement around LLMs and, like all these people who would say, what's an LLM? And like, how does AI work? And I don't know if maybe you could have imagined that when you were 19.
Yeah, no, I mean, I think certainly not on the scale that things are happening today. When I was in college and sort of just starting to get interested in everything, I knew I wanted to do something generally in the space of artificial intelligence. And, at the time it was like kind of a weird thing to be working on and not obviously going anywhere, not obviously the, kind of most successful, application of computer science techniques. And I emailed everybody in the department and said, hey, I want to do something with you. And the natural language processing people got back to me first. And I think that's actually sort of how I wound up here rather than somewhere else. Yeah, well, I mean, at the same time, I think it was always clear to a lot of people who are working in natural language processing and a lot of sort of what the appeal of that field was that many of these more sort of general questions about the nature of intelligence and the nature of thought and all that are kind of closer to the surface in language than they are in things like vision or robotics. And, so maybe the NLP chauvinist in me says that we shouldn't be surprised that we've wound up in a world where all of these sort of big general purpose AI developments have come out of training on language data. But at the same time, I think everybody is surprised that, they've come as quickly as they have.
You told me that I think when you were younger, it wasn't at all clear that this was a career path that felt like a good one or, a certain one.
Yeah, I mean, just in the sense that there were, this was something that you could do as an academic and you could write machine learning papers and you could, prove some nice theorems. But it was so far divorced from practical application other than, the various sort of simplest tools that we really had since the 60s, 70s, 80s. So, I think that has been the big surprise that, on really just in the last decade and a half, has gone from being this hey, in principle, some of this will be useful to somebody someday to, changing the world now.
When did you feel like the pendulum started to swing inside academia where people were like, maybe the man on the street doesn't realize this, but this is going to be a big deal and we can kind of sense that it is going to be?
Yeah. Well, so when I was going around sort of interviewing at PhD programs in 2011, 2012, I guess, there were certain labs and certain departments that were saying, hey, all this neural net stuff, it seems like it's starting to work. It's going to be a really big deal. Pay attention to this. And, at the same time, I was getting advice from other people that I were talking to saying, oh, no, this is just a fad. This is, the same thing is going to happen to this that happened to it in the 80s. And be careful what you work on. And, as a result, I think I, was sort of late to the game relative to the group of people who were working on these things in academia. But I think even then it was, or, within a couple of years of that, it was clear. And it was clear to the people who were really paying attention at the time that this was going somewhere.
And you make an important point because in the 1980s, there was a surge of interest. Like, this is not the first surge of interest in artificial intelligence. So,
well, and not just in artificial intelligence, but in sort of neural networks specifically.
Right. And so I'm sure there were people who thought we've seen this movie before, and when we know where it goes, which is kind of nowhere.
Yeah. Well, or, I think now with the benefit of hindsight, we can say, oh, yeah, actually they had a bunch of great ideas in the late 80s, early 90s, and just didn't have the sort of hardware or the data resources to prove them out. And that, many of the things that we're sort of doing now, many of the, sort of basic building blocks that sit underneath something like ChatGPT are really things that we've had the ideas for that long.
Do you remember what the first indication was that average people would started to care about this, and like when you started to realize that this wasn't just MIT or your department or whatever?
Yeah, well, I mean, so I think, probably many people would agree that the sort of watershed moment here was when ChatGPT came out. But I think the really interesting thing there was that, that was based on a set of language models that had been around for, a year or something at that point. And that within the academic world, when those first super high quality language models came out, that was kind of, for the research community, oh wow, this is moving faster than we expected. But then the surprising thing, at least the surprising thing to me, was that was not the moment when it also caught the public attention, and instead it was a change really not in the sort of underlying machine learning technology, but just in the way that it was presented, that caused everyone to become aware of it. Right, that the way you interacted with one of these language models went from being via this very complicated API or this dashboard that looked like the control panel for a spaceship to, hey, it's just a chat bot.
Right.
You can type into the box the way you type into somebody on Instant Messenger or whatever.
The repackaging mattered.
Yeah.
What do you think? I wonder what the upsides and the downsides are to so much attention being. I just wonder if you think about those two sides of things.
Yeah. No, I mean, certainly the upsides are it's, kind of nice to have resources directed at this class of problems that we always, have thought were really interesting. And to have so much, sort of public interest in these things and be able to talk about them. I don't know if this is actually a downside, but I think it has substantially changed the way we've had to think about, teaching all of this material at MIT, because it's gone from being, again, a sort of niche grad special topics kind of subject to something that, everyone in the business school wants to take a class about this. Everyone in the biology department wants to take a class about this. We had, some like double-digit number of people from the Harvard School of Public Health in the NLP class the last time it was offered. So, just kind of who the audience is has changed a lot. And, I think that's a lot of work, but it's also in some ways like a positive thing. It's very exciting to be able to talk about these things. And then, I guess maybe the real downside is just that it would be, sometimes it feels like it would be nice to be able to continue to, sort of lead a life of quiet contemplation and think deeply about these things without having to be able to, react to every development in the news. But obviously that's just not the world that we live in anymore.
Right. All right, so let me ask a little bit about your research and then get into some of that news. I know that one of the things that you focused on is building machine learning models that are a little bit more like us. And you've used this example of baking a cake. So like if, you're going to learn to bake a cake, you might bake a few cakes, you might read a recipe. But if you think about a machine learning model, they need a ton of input. Do you think that's going to change, and that these models are going to become a little bit more like us, and you don't have to bake 1,000 cakes to figure it out?
Well, and I mean, this was an example that I like to use a lot, even sort of when I was, or especially when I was starting at MIT, and is something where I think, the rules have already changed a little bit, even in the time that I've been here, in the sense that if I want to take, in 2019, say, if I wanted to take a language model and get it to perform some sort of complicated new task, it was pretty hard even then to say, okay, here are the instructions that you need to follow, and here's a sort of, natural language specification of the task that you're trying to perform. You really needed lots and lots and lots of demonstrations. Now, you can... the cake example is complicated because it requires being embodied in the world and it requires steering a robot around. But, some new mathematical technique, some new programming library you want to use, you can just drop some instructions into the input for one of these models, and it sort of learns how to do it just from that data. So, in some ways, I think understanding that phenomenon, making it more robust, making it so that, when I say something to one of these models once, it gets assimilated into some sort of coherent underlying model of the world, as opposed to just, being forgotten as soon as I change what the input is. Those are still really important questions, but in some ways, I feel like we are already closer to being able to realize that grand vision of, but I guess with the caveat that what you need to get to that point still is very, very different from, what a human language learner or a human learner more generally needs to see in order to get to the point where it exhibits, sort of adult-like language competence.
How does that, as you've indicated, we've already kind of come down the curve, like having to feed in all this stuff. How does that change the tech landscape, or even, in terms of like application of, these models and what they can do for us?
Yeah. Well, okay, so I guess a couple of answers to that question. One is there was this sort of beautiful moment when it felt like, okay, these models are super, data hungry and compute hungry, and if we can just make them more efficient in that regard and maybe, borrow inspiration from things that we've learned from sort of developmental psychology, from things about human language acquisition, that will wind up both with, machine learning models that are more useful in their own right, and maybe with some new insights about how human language learning works. That, sort of figuring out how do you learn efficiently from small amounts of data was both the critical question for building better AI systems and for building better, sort of understanding of human intelligence. I think that's still true, but I think it is no longer the case that you really need to answer all of those questions to build the best language model today. And that really there's been some sort of divergence between what does it look like to apply these tools as systems for improving our understanding of human language, and the, just like what do you do given that we do have access to these huge data and compute and whatever resources today. And, maybe that's something that'll come back around the other way at some point in the future, but that feels like it's been one of the big changes in just how we think about this class of problems. But then the other thing that feels like it's changed a lot, sort of, especially in relation to science, is just that we've really gone from being an engineering discipline to a scientific discipline in some ways, right? That it used to be that you would say, okay, I want to build a model that exhibits capabilities X, Y, and Z, and so I'm going to design it to some specification that ensures that it's going to exhibit those capabilities. Now we have this recipe that says, okay, we have our sort of basic, neural net toolkit, throw it at as much data as you can get your hands on, using as much compute as you can get your hands on, you're going to get some kind of model out. And it's sort of hard to predict ahead of time what capabilities that model is going to have, and certainly to understand what is going on inside it, in virtue of which it's able to sort of do all of the things that we see it doing. And so a lot of what we're doing now is just more that kind of scientific understanding of these models, trying to understand how they work, trying to understand what makes them work the way they do, and kind of what's going on inside.
So, how far, if at all, do you think we've gotten from the throw as much data as you have at this, throw as much compute as you have at this, and that's best?
So, sorry, how far in?
Well, it feels like over the last few years, and we can, I think a little bit about DeepSeek that recently, came from China, and this question of, so it felt like the amount of compute had been going up. You saw people like Sam Altman, just raising huge sums of money, right? Because that's what it felt like you needed to do, right? You needed to get as much compute power as you could. You needed to have, as much data as you could possibly have. Have we broken from that, or are we kind of still on that path?
No, I think we're kind of still in that paradigm, in the sense that, maybe the big thing that's changed with DeepSeek and with these O-series models from OpenAI and various other things that are going on is a change in where that computation gets allocated. That we're not using it just to train the models, but we're also using it to, sort of let them think for longer as they're coming up with their answers to inputs from people. But, again, this is an old idea. And if you think back even to like the IBM chess playing system,
Gary Kasparov,
that was all search and essentially no learning. And in some ways, what has changed in the last couple of months, because that's how quickly things are,
Yeah.
are moving now, is that we're using those same large-scale computational resources, but in a more sort of deep blue-like way.
So when you saw and sort of processed the release of DeepSeek, to you, was that a game-changing moment or not necessarily? Especially in thinking about it in the context of, let's say, the U.S. tech industry and all these big companies and the roadmap they've been pursuing.
Yeah. Yeah. I mean, so one thing is, I should say, I'm probably not the person to, talk about the detailed geopolitics of all
Yeah.
of this. I mean, from my perspective, the thing that felt important or surprising there is just how quickly we were able to wind up with a sort of open replication of, these models that had this knob that you could sort of crank up the amount of thinking that they were doing at, when you ask them a question rather than when you were training them. And, again, there have been, I think, sort of ideas for how to do this, proposals for how to do this in the academic literature for years. But, as in the case of our, discussion about the 80s, it just like takes the compute and the engineering know-how to figure out how to scale them up, to validate them. And that used to be the sort of thing that I think only a handful of organizations in the world were able to do. And maybe the big lesson from this DeepSeek thing is now that those skills are sufficiently dispersed that that lots of people can play this game.
The venture capitalist Mark Andreessen talked about it as a Sputnik moment. I wonder if when you saw this, you thought, oh my gosh, America, we're a little behind here. And I mentioned to you before we started rolling that, we had talked to Neil Thompson months ago, and he was like, China is, accomplishing a lot on AI. And he was a little, I don't know if concerned is the right word, but it might be the right word.
Yeah. Yeah, I mean, so I think some, there's the just who has the sort of technical know-how to do these things, and how long does it take to, for big results like this to get reproduced is one question. What are the actual computational resources that you need to do these kinds of things, and does it require access to sort of OpenAI levels of compute or nation-state levels of compute, or is it the sort of thing that small whatever small firms can do? That feels like the other big question. And I think there we just don't really know enough about what's gone on with DeepSeek specifically, or how many of those claims to take at face value to, I think, really yet have an understanding of what's happening there.
Do you worry at all about, and this is more of an academia kind of question in some ways, although I guess a lot of research is going on in industry too, but do you worry that in a whole world where everybody is working on AI, it's not just one country, that we are maybe losing an edge that we once had?
Well, so maybe two pieces of that answer. One is that right now everybody is talking about this in terms of the U.S. and China, and I think if it's really the case that you can train one of these models now up to the level of the very best ones for millions of dollars, then it's not just about U.S. and China. Right. Everybody in the world is going to have access to one of these things. If that's not the case, right, and if you still really do need sort of billions of dollars of infrastructure investment, then that starts to look a little bit different. But certainly there are people here and people there, and probably people in other countries as well, who are starting to make those kinds of investments. And then I think in terms of whether you worry about this as somebody sitting in academia, certainly the set of questions that we work on and that we can work on, and that it is useful for us to work on relative for industry to work on, has changed a lot in the last couple of years. And I think there are lots of people who have sort of woken up one morning and found that the thing that they thought was an academic research problem is maybe no longer an academic research problem. But there's still an enormous amount for academia in whatever country to do here.
You mentioned business. Let's build on that a little bit. I'm sure you talk to people in business all the time. I feel like that's probably a product of the last few years, and business wanting to interface so much more with computer science departments. I mean, in your experience, from what people have told you, from what you've seen, I feel like both in academia and in business, people spend a lot of time thinking about use cases and like what works and what doesn't. In your experience, what kinds of use cases have worked the best, and what have you seen that's like hasn't worked that well?
Yeah, I mean, I think. Well, okay, so another interesting thing that happened when actually the GPT-2 model came out, which I think that was actually, at least for me, the big kind of, oh, things are about to change substantially
Okay.
moment, was that they had all of these, example outputs from the system, and it was producing, 2 paragraphs of coherent text on some new topic. And at the time, this was amazing because, if you got a couple of sentences, you were lucky. But, if you sort of read the blog post or the paper or whatever very closely, the way they'd gotten these really nice looking paragraphs was to, have the model do 10 tries or 20 tries, and then they pick their favorites.
Okay.
And I think there was a lot of sort of finger wagging from academia that says, oh, well, if you can't, if only the top 5% of outputs from your system look this good, and most of the time it looks like crap, then I'm probably not supposed to say
fine.
that on the podcast.
It's a podcast.
Okay. Then maybe this is not really worth looking at or worth taking seriously at all. And that was a terrible take, in the sense that if you've gotten to the place where a person can validate a set of 20 machine-generated outputs rather than having to write those things themselves, already you've created an enormous sort of change in the kinds of things that people can do, as long as there is a person in the loop. And I think for a long time we thought about these things. And I think, in a lot of sort of industry settings, people still think about these things from a sort of pure automation standpoint. And to speak at the sort of most general level, I think it is still the case that many of the most sophisticated, Gen AI systems that you can use there break in sufficiently unpredictable or weird ways that you don't necessarily want to have them acting totally autonomously. But if you have a problem where you can put a human in the loop and quickly just like verify that the output of one of these systems looks sensible, looks correct, looks acceptable, then you can do sort of amazing things with productivity. So I think, that's maybe the high order bit there, is that if you have the kind of application where validation is easy for a person to do, then these things just work incredibly well. And if you don't, if it's hard for people to verify the correctness of outputs, or just requires a bunch of human labor to verify the correctness of outputs, or there isn't even like a well-defined notion of correctness, then it's less clear that we're yet in a position to use these things. And, again, I think that actually sets up an incredibly exciting research agenda, which is just how do you, on one hand, make the outputs of these systems more legible to people, and how do you design machine learning systems for a world in which sort of human-in-the-loop accuracy is really the primary criterion that you care about, rather than just like doing well on some benchmark data set.
Well, it's interesting too, because David Otter, who we also recently had on the show, has talked about that, one of the things that's really challenging for humans, when you talk about humans in the loop, is to sort of constantly be on alert, but not really. Like sort of, Jacob, I'm going to drive you, go in this car, it's self-driving, you don't really need to pay attention, but you should pay attention, because like 1% of the time it messes up.
Yeah.
Well, that's hard, because, you're going to eventually take a nap, check your phone, eat a sandwich, something, right? Because like almost none of the time does it actually need you. And then when it does need you, you've checked out. You're like reading an article, on your phone. And so, I think that's in some ways, it's like hard to ask somebody, make sure you're alert to problems, but mostly AI will take care of it.
Yeah. Well, right. And then, I think in self-driving cars, as in all of the other applications, we just really need to think about what that interaction looks like, so that, either we are asking people to be on alert all the time, and maybe we would, sort of synthetically do attention checks or whatever periodically, just to make sure that they're not falling asleep. No, seriously. Or build the cars to be much more conservative about where they ask for human input, or, set things up so that we always know there's a long on-ramp and lots of lead time before the person needs to step in and take control. And I think there are analogs of those kinds of designs in, in things that you would want to do with like AI assistants for programming as well. Right. And we just have to figure out what those interfaces look like.
I'll ask you another Otter-inspired question, which is, there's obviously a lot of excitement around AI, but the other side of it, and I wonder how much of this you hear or think about, is especially this is fascinating to me, but especially in technologically advanced countries, there's huge fear of AI. People are very worried that it will take their jobs. And again, it doesn't tend to be in places where people have less education. It tends to be in places where people have more education. How do you think about that fear? And then obviously like the world that you're in where there's like all this excitement about how things are moving forward.
Yeah. No, I mean, I think some amount of that is actually justified in the sense that, I do think the economy, the job market is going to look very different 5 years from now in ways that are sort of hard for us to predict. And, I wish we lived in a world where, I think there is a good endpoint there. I wish we lived in a world where we had more time to sort of figure out how to ramp up to that. But, it seems like maybe we don't. And, I think that doesn't immediately look like everybody being replaced by a robot. But I think what it means to be a software engineer, the set of skills that you need to be a software engineer or a customer support agent are going to change substantially from what they look like now. And we do need, at the sort of changes in the educational infrastructure, changes in the policy landscape to get us ready for that.
Given that obviously you don't know in 5 years how the employment picture is going to look different, how do you anticipate it might be different? And you indicated customer service, you indicated software engineering. I mean, are these things that are going to change radically, and are there other kinds of jobs that you think were?
I think so. Again, I think even the people who are starting undergrad computer science degrees at MIT right now are going to graduate into a world where most code gets written with AI assistance. And, so again, I think I would be very surprised if in the future, the ways in which that sort of AI code writing happens looks like the way we do it right now, where you just have this like super smart autocomplete or a chatbot. I think, what a software development interface looks like is going to need to change pretty radically. And the way we train people to write code is going to need to change. And I think it's going to be much less about coming up with clever algorithmic solutions to problems and more about coming up with sort of developing the skill of reading things and verifying that they're correct. And maybe even more than reading code, just reading and writing specifications for what code ought to do. And, in some ways that's exciting. And they're, these are things that people have been thinking about for a long time, but they're not the bulk of the undergrad curriculum right now.
To that education piece, do you worry that we don't change fast enough? And I'm not really talking about MIT here because it's just a few people in a whole, a huge country.
Well, right. And, the reality is that I think many MIT grads are not spending that long in the role of just being the ones writing the code themselves. But no, I mean, I do worry that we're not going to be able to update things fast enough. And that, in the period while things are changing as rapidly as they are, it's just going to be hard for everyone to keep up with the moving target of what, one of these systems can do today and how to teach to that thing.
But it sounds like you think what employers want will shift. And the question is, like, can employees and the people who train those people shift fast enough? And you're not sure that they're moving at the same pace.
Yeah.
Yeah. I know one of the things you've thought about a lot and worked on is the ability of, our ability to use English. Let's say somebody doesn't code, but how well can we use English to maybe create a technical product? And I wonder where that stands and how that's changing the landscape.
Well, I mean, already, right? You can write down a
Yes.
detailed natural language description of an image that you want to create, and
Exactly.
an image pops out of a piece of software that you want to create, and a piece of software pops out. This is incredible, and it works well enough most of the time that it's easy to sort of see how we get from here to a world where that is the main interface for doing large amounts of I hesitate to call it creative work, but the creation of software artifacts and images and things like that. At the same time, it is certainly not the case that English is the best language for specifying absolutely everything that we want to specify,
Right.
and maybe even more than that. I think a lot of what is hard about getting a piece of code that does what you want it to do, or creating an image that looks like you want it to look, or coming up with a sort of textual summary of some facts that you're trying to learn, a lesson plan, whatever, is that you don't even quite know as a user, as a human, what the right questions to ask are in the first place, and that there's some things that come out in the process of building out one of these systems, or of doing research, or of trying to fashion a creative artifact that allow you to figure out what the question you were actually trying to ask all along was. And I think that's something that we're still not great at right now, is building like systems that cause people to ask better questions, or systems that surface to people considerations in programming problems, say, that they hadn't even thought about before trying to engineer these systems.
Can you talk for a little bit about an inference budget?
Yeah.
Like what it is and why it matters when it comes to AI?
Well, okay, so now that we live in the world of O1 and DeepSeek and whatever, like we were saying before, the main thing that has changed is that in addition to whatever resources you were willing to expend training a model, which I think we've been thinking about for a long time and have a pretty good picture of, it's now the case that when I ask a question to my language model, I have some choice in how hard I want it to think in the course of coming up with an answer. And so that is in parts of the literature referred to as an inference budget. Basically, how much additional work do you allow your model to do to come up with an answer once you've already trained it?
Okay. So I want to give you a quote from Atul Paul Jacob, who was the lead author on a paper, talks a little bit about this, former graduate student at CSAIL. And this is his quote. "If we know that a human's about to make a mistake, having seen how they have behaved before, an AI agent could step in and offer a better way to do it, or the agent could adapt to the weaknesses that its human collaborators have." And so I read that. I thought back to this conversation I had with Andrew Lowe a few months back about how bad people's decisions often are around their finances. The idea is like buy low, sell high, but people often do the inverse because they get very scared. The market's dropping. They sell all their stocks is like the exact wrong thing to do. And it ends up having really negative consequences for, like, let's say, the retirement funds. So I wonder, if you do see that ability somehow to see what that weakness is, like, Jacob, he always makes these kinds of he freaks out when this stuff. How do we stop that from happening, or is there a way to help people with those?
Yeah, I mean, okay, so that's a funny paper, because we were writing that, before the current blow up in inference time compute. I think there were lots of people here, Jacob among them, who sort of, saw that that's where things were going. But that was a paper not about, about sort of building models like, the most recent language models we have today that have a little knob that you can tune that determines how much or how little they should think. But then using that not just to solve AI problems, but actually to model human behavior and to back out of examples of human behavior information about who was thinking hard and who was thinking not so hard. And you can do all these kinds of things where if you say, okay, well, let me figure out, for this chess player, where to dial in the knob to best simulate their behavior, and then that
Right.
turns out to be a really good proxy for just like how good they are
Right.
at chess. And that, I think, coming all the way back to the conversation we were having at the beginning about like, what's the relationship between AI as a tool for understanding human intelligence and AI as a tool for just system building? That actually, I think, is something sort of exciting that we can start to do now more on the science of human intelligence side. That you can think of tools like DeepSeek, O1, whatever, maybe as tools for reasoning about human reasoning and human behavior, and and I think there's a bunch of different applications where you can imagine the ability to sort of model human thought processes being super useful. Something else that we've been thinking about a lot in my group lately, led by my student Alexis Ross, is the classroom, right? And if you can sort of infer from the kinds of mistakes a student is making, what it is that they misunderstand about whatever it is that you're trying to teach them, then you can deliver more effective and more personalized teaching. And so I think maybe the high level theme there is that, like you're saying, there's a lot of room to use these tools, not just to solve the problems that we put in front of them, but actually draw inferences about people in a way that then lets us be more useful to people.
It also goes to the conversation about agents, which is talked about a lot in business, but you mentioned that kind of like potential in education. We talked about in finance. Is your sense that, when we look a few years down the road, people are going to have these kind of agents to help them with fill in the blank, with learning algebra, with managing their money, whatever it is?
Yeah. I mean, probably in some fashion. And I think what that looks like depends on how well we can figure out what, again, the sort of interface between the agent and the human user looks like. I have a hard time imagining a world where there's a large number of these things operating sort of entirely autonomously of any human oversight. And I think that would be kind of a scary world to be in. But I think there are ways of building these systems, research questions to be answered around how you, sort of make them work better with people.
Do you feel like when it comes to this question of education, which is, it's a system I think a lot about, and there's shortages of teachers. Do you imagine that there really could be, I feel like there's often a gap between what people in tech imagine can be implemented in education, what can actually be implemented in education. This is like a big country and big K through 12 system. Do you think that really could revolutionize education in a meaningful way?
Yes, but I don't think that looks like, every student has their personal AI tutor and they're only talking to the AI tutor and not to any human. Obviously, like, the social component of learning is incredibly important. Having a personal sense of personal connection to the person teaching you is incredibly important. But I think there are tools that we can build to assist human teachers to be more effective, right? To have a clearer picture of where an entire classroom is or where an individual learner is, or to figure out how to supplement, sort of human instruction and human interaction with one-on-one practice that maybe is more adaptive or more intelligent.
A final and pretty much unrelated question. You have done some work on sperm whale communication. How, given everything we've talked about, did that come to be? Seems like it's kind of outside your normal area of work.
Yeah.
I don't see like that many sperm whales here in Kendall Square.
No. No. Well, the ones that we work with are all in Dominica and the Caribbean. But funnily enough, that project did actually come about in ways that follow pretty closely from things that we've been talking about, in the sense that right when I started at MIT, I went to the CSAIL faculty retreat over the summer and gave a little presentation about some research that I was working on. And at the time, it was about sort of interpretability of AI systems, understanding the sort of internal computations or the internal representations being built by neural nets through the lens of machine translation, saying, can I take, some language model's representation of a problem and translate it into English so that a person can figure out how it's thinking about the problem. And Daniela Roos, the CSAIL director, came up to me afterwards and said, do you like weird translation problems? I have a weird translation problem from you. And, it was around the time
Did you think she was about to be like Mandarin or Danish
I
or something?
don't know that I knew what I was expecting. No, but, at the time, she and a bunch of other people who had been at the Radcliffe Institute at Harvard were putting together this project, SETI, CETI, for the Cetacean Translation Initiative. And that's kind of how I got into it, is actually, sort of interpretability of animal systems through application of tools that we'd started thinking about in the context of interpretation of AI systems.
And how far have you gotten in figuring out how sperm whales communicate?
There's still a long way to go. Okay. So Pratyusha Sharma, who's a grad student here, who's co-advised with me, and Antonio Torralba, has done some just like really beautiful work in the last couple of years teasing apart the structure, the sort of syntax or the grammar of sperm whale vocalizations, and has learned a bunch of things that weren't previously known there. And we're like just starting to be able to draw the first links between vocalization and behavior, things that whales are going to do in the future based on what they're saying now. But I would say we're a very long way still from anything that one would be inclined to call translation.
Is it exciting work?
It's super fun. Yeah. And just like a very nice change of pace, being able to talk to marine biologists and, go out on a boat in the Caribbean to do field work and all that kind of stuff.
Yeah, a little bit of a change, just a touch from here. Jacob Andreas is an associate professor of electrical engineering and computer science. He's a principal investigator at CSAIL. Thank you so much for your time.
Thank you.
It was great.